Hi, I'm Rusty Tchernis. I'll be talking about mortise and tenon joints. Mortise and tenon joints is a very important joint. In fact, it's so important it has its own magazine, but it's used in many different things. It's used in construction, it's used in casework, and chair making. And I'll talk today about two different types of mortise and tenon joints in general, and those are the ones that you will use in casework as a rectangular mortise and tenon joint. And I'll also talk about round mortise and tenon joints used specifically in green chair making. But we will start with casework. The basic definition is that you will have an elongated tenon that's going to be enclosed on at least four sides by a mortise. It can be a through mortise and tenon, so in this case it goes all the way through from one side of the wall in this little whiskey cabinet all the way out, and then it is wedged from the outside. Or it can be a blind mortise and tenon joint like this one, where it doesn't go all the way through, and then each of those can be wedged in different ways. So a through mortise and tenon can be wedged either this way, or it can be tusked when the mortise is elongated and there's another wedge going vertically through it. Those are used for pieces that need to be disassembled and moved. For example, a bed or a trestle table. Those are very used also in Moravian type workbenches. A blind mortise and tenon joint is usually used in a frame like this door frame with a floating panel. There's tenons going all the way from the rails into the stiles of the door. Okay, so some of the things that are important to know about mortise and tenon is the fit of the joint. Usually you'd like it to be snug, but not so snug that you cannot, once you assemble it, that you cannot disassemble it. And then it's important to have a little bit of freedom, so again, you can put it in and be able to disassemble it, whether when you're doing dry fitting or if you think about repairability of the piece. And so it's important to know where the strengths come in. So the strength of the mortise and tenon joint comes from continuous wood fibers. So continuous wood fibers going up and down here and sideways here. That is the end grain, so the fibers that are chopped here and here, they provide very little support. And so introducing a little bit of movement, specifically into the end grain dimension, if you will, helps to be able to put the joint in and out. When you're cutting this joint, it's important to have what's known as a friction fit. That is, once I assemble it, it's not going to fall out. If it's too loose, it's going to fall. So what we'll do now is we will cut the other side, another tenon just like this. Notice that this mortise and tenon joint has a hole going directly through both mortise and tenon, and you can put a peg through it that will lock the mortise inside the tenon. Sometimes you'll see those with two pegs. There's a beautiful piece in the High Museum of Newport Furniture, Toll Hutch, and it has two, and they offset a little bit. This is to make sure that the fibers are not split. If you put two above each other, it really weakens the fibers in between those two pegs. So sometimes you'll offset them. But we're going to do something similar, but we're going to do a drawboard mortise and tenon. This is when you making a hole a little bit offset on the tenon, and so as you put the peg in, it really draws the joint together. So it not only locks, it also assembles this joint and makes it really, really tight. So the first thing that's most important is to make sure that your layout is pristine, all the lines are straight. We're going to do all the work by hand, but I'll tell you in a few words how this mortise was chopped. Usually if you're doing it by hand, you will size your mortise. Well, it's most accurate if you size your mortise to the size of your chisel. So this is a mortise and chisel, sometimes called a pick sticker. And so this mortise was cut exactly with this chisel, and the size of it is exactly the size of the chisel. Once you have the mortise cut, then you can transfer the size onto the piece to make your tenon, and that's what we're going to do next. So this mortise is about 1 inch deep, and I'm going to be transferring all those sizes to this piece. So I'll start by just marking what side I'll be cutting, what sides are going to be up. I'll put a little marriage marker, a triangle, that shows me how it will be aligned. Next thing, I will set, again, this mortising gauge was already set to this piece, and I just need to make sure that I know what was the reference space. This was the reference space here. And so you can see that mortising gauge has 2 pins, and so the distance between those pins was set to the size of this chisel, just distance between the tips of it. And I know which side I was referencing from. This was the side. So I'll be doing the same thing on the other side here. So I'll just make one mark, make the other mark, and then I can connect those with my marking knife. Okay. And I'll also measure the depth of it to be in 1 inch. And set the shoulder. So I'll be doing all of my marking with a marking knife and creating a knife wall. It's important not to make a knife mark really hard from the beginning because it's easy to skip. So I'll be transferring this. Now, I will also say that the easiest way to make the mortise and tenon or any joint is to start with really square stock. If the stock is a little bit out of square, you can still do this. It becomes a little bit more difficult. Because this stock was square on all 4 sides, I don't need to worry so much about the reference faces. If your stock is slightly out of square, it's really important to keep track of your reference faces. Okay, so now that I have marked all of the faces around, I'm going to start by marking the cheeks of my tenon and I'll cut the shoulders first, then cut off the cheeks, and then I will size it to the width of the joint. And again, I have the 2 pins, so I can either mark it with the spin gauge, again, it's important that I remember what size am I referencing from. Okay, so I'll just highlight those lines with a pencil. So this is one, this is the other, and again here. So again, there's the shoulder line that I marked with a marking knife on both sides. And there's a cheek line that I'll be sawing on both sides. So I'll just connect the 2 of them. I can do it with mortising gauge, but it's a little bit tricky to mark on the end grain. The gauge tend to really run off, so I'm just going to do it with a pencil. Okay, I'm going to connect the 2 shoulder lines on the tenon, just to give myself a guide for when I'm going to saw the cheeks. I will also start by sewing it a little bit fat so I can really dial it in for the fit into the mortise. Okay, so first thing, I'll create a knife wall here. Again, I'm thinking about what will be visible. The only place that will be visible will be the cheek line. Yeah, this is going to be a blind joint. So I'm just going to deepen those two marks to make sure that they nicely defined. Just keeping in mind that those will be the two spots that will be visible. And then take a small chip off. This is where the saw is going to go. So this creates a place for the saw to ride against and really helps with this being a clean joint. So then the saw goes right into the knife wall. I'm supporting it on the other side with my finger. And once I get to the cheek line, I'm going to stop. I'm not, I'm in close on the other side, so there's a few more strokes. Okay. And then do the same thing on the other side. Again, define the knife wall. Okay, so this defines the shoulder cut on both sides. So the next part is to cut off the cheeks. So I have the vertical line, that's what's going to guide me. And again, I'm going to start by making it a little bit oversized, and then we'll fit it exactly to the mortise. There it is. Okay. I'll also, while I'm here, we'll clean up that corner, make sure there's no loose fibers stuck. Okay, that's one. And I'm leaving the line right now so I can plane it down to fit the joint. Okay. So let's see how it fits. So it's fat in both corners, which is great because now I really pare it down with a plane, or you can use a router plane as well. Still a little tight on both. Oh, this side goes in a little bit, but still could be still a little fat. And I'm checking, I have 2 marks that show me that this is the way this joint fits. So this side is fitting a little bit better. Couple more. I'm checking also which side do I need to take more off. So they're pretty close. Okay, so this side I shouldn't be touching anymore. It's a little loose maybe, but this one is okay. This one needs adjustment. Okay, that fits pretty well. So now I'm going to transfer the size of it. Again, normally I will have, depending how the joint will be constructed, I will have the marks where the outside fits. Just transfer it from the tenon on, transfer it from the piece itself. So I have those 2 marks here, and I can, again, this dimension I'm not going to worry about as much because I want a little bit of space to be able to wiggle the joint in. So again, I'm gonna cut the shoulder first. So same process. Now, I don't necessarily need to create a knife line here because I have the shoulders to guide me. And now I can cut the waist off right here. Okay. Before I try to assemble it, I'm going to take the corners off. Sometimes the joint can really get hung up on the sharp corners. if we're close. Feels like it's still a little tight. This is fine. And we need to, it's a little bit long as well. So I'm gonna take a few shavings. Okay, so the length is okay, maybe a little tight, but this corner is still very tight. Okay. So it's pretty tight, fits on both sides, and I'm okay with the length. So the next step will be to draw bore it. So again, it's important that you have a little bit of movement, because if it's so tight that you cannot pull it out, then you have just one go at it. So I already have drilled the hole for the pin in the mortise. So now I need to transfer it to the tenon, and then I will offset it by about 1/16 of an inch. So the easiest way to do it is to use a bit that has a center cut, either an auger bit or a spur bit like this one. And that transfers the location of the center, can you get it, onto the tenon. So then I'm going to disassemble it. I have this location right here, and then I'm going to move it inside toward the shoulder by about 1/16 of an inch, perpendicular to the shoulder. Going to define the center for the hole with an awl. These cheeks we just cut off, they pretty useful. I can use it as a backup so that I don't blow out on the other side when I drill it. Okay, so just one more time, I'll point out. The line represents the center that I transferred from the mortise, and the dot is going to be the center, the offset center, and you can see I'm moving it about 1/16 of an inch. Okay, you ready?
Yep.
So if everything worked well, but you can see there's a little bit of a shoulder right there. So hopefully that's going to be enough to pull the joint in, even though it's nice and tight already. Okay, so let's make a pin. This is just the right size, but I'm going to sharpen it a little bit so it can get through that offset shoulder. Let me cut it first. The reason for this bevel is just to get over the offset shoulder, however small it is. Okay. And so even that tiny little offset, you can see how nice and tight this joint is right here. Okay, and the rest I'll just use a flush trim saw to cut the pin out. If I were to disassemble it, let's say I'm building a door and this was just a test fit, I'll just drill it out with a smaller diameter drill so as not to drill into the offset. Okay, there it is. Drawer-borne mortise and tenon. I mentioned earlier that the mortise itself, I just chopped with the mortise and chisel, and because it's sized exactly to the chisel, I just chop across the fibers both ways, leaving the waste out. The trick is to stay away from the shoulder, particularly if the shoulder is going to be exposed, not to dent it. A different way of doing this, and on this joint, I cut the mortise itself with a hollow chisel mortiser. It's a designated machine specifically for doing the rectangular mortises. There's a number of ways you can do it. You can have the mortising machine, or you can drill it first on just a drill press and then square out the edges. The important part is the layout ahead of time. So next thing I'll talk about are mortise and tenon joints in greenwood chairs. So both of those chairs are built with mortise and tenon joints. And there are two different types of mortise and tenon joints in those chairs. In this chair, all of the mortise and tenon joints are parallel. And this chair, the legs are attached to the seat with a tapered mortise and tenon joint. And there's benefits to both types, and we'll talk about one at a time. So let's start with parallel or straight mortise and tenon joints. So this chair is made out of oak and it has a reed seat. It's 5.5 pounds in weight, and the strength of this comes specifically from the joinery. The mortises are about 5/8, and they go into legs that are about 1.5 inches, 1.25 inches. There are multiple reasons I can make those joints very strong. One is it's going to be a very tight joint. Two is I'm going to use moisture content to make this joint even stronger. That is, all of the tenons will be hyper-dried, so I'm going to put all the tenons in the kiln and dry them until all possible measurable moisture is out of it, so it becomes bone dry. And once the joint is assembled, the tenon swells inside the mortise. Grain orientation is another thing I will be really careful about, and I will notice that, so if you think about the way that the tree grows, there's three different dimensions. One is the longitudinal dimension, and the wood doesn't really move in that dimension at all. And then there's tangential plane that goes along with the growth ring, and radial plane that goes from pith to the bark. The wood does not move as much in the radial plane as it does in tangential. That is, it moves along the growth ring much more than across growth rings. And so I will be careful to align the components so that they move together. So for example, the simple rule of thumb is that the growth rings go perpendicular to the long wood fibers of the joining piece. So this is the longitudinal dimension, and I will make sure that my growth rings go perpendicular to it, so that when the leg moves, my rung moves with it, and in this dimension it will move not at all, or much less, along with dimension that in a leg that doesn't move at all. Okay, so I marked the growth rings here with a pencil so they're a little bit easier to see. So this rung is going to be expanding and contracting in this dimension much more than in this dimension. And so I will align those growth rings to go perpendicular to the leg. So when I drive the joint together and when the joint is assembled, the rung is going to move much less up and down because the leg's not expanding in that dimension, but they will be expanding and contracting together horizontally. Okay, so the next question is, well, how do you cut a round tenon? Making a mortise is pretty easy. You can just use a drill, hand drill, or bit and brace. There are multiple ways to cut a round tenon. One of them is just do it on a lathe, which is how this side was cut. A different way, the way I prefer, is to use a hollow auger. And this is made by A.A. Woods, a company that was actually in Atlanta, and this was made about 100 years ago, about 1916. And this is an adjustable hollow auger or a tenon cutter. And the way you can do this, there's two ways. One is that you can put a piece in a vise. So this mortise also has a depth stop, so I know that my mortise now is 1 inch long. The fit of the joint, again, I would like it to be fitting with a squeak when the tenon is bone dry. We talked about orientation of the wood fibers, and the last component of a strong joint is going to be sizing with hide glue. So let me explain how that works. Because this joint is going to be so tight that I can hardly put it in, this squeaking kind of tells you how well it fits. If I were to just use a regular Titebond 2 or 1 or any white glue, by the time I assemble this joint, all the glue will be sheared off from the tenon. So what hide glue allows me to do is, because it's reversible, that is, I can activate it when the glue is dry, moisture will make it tacky again. I'm going to apply a first layer of glue, both to the tenon and to the mortise. I will wipe it off, and in the process of wiping it off, I will rub the glue into the wood fibers. Now when both parts are dry, I will put the second layer that will both activate the first layer of glue and serve as a lubricant, allowing me to assemble the joint. Now, almost everything in the second layer will be sheared off in the assembly, but the first layer that's in the fibers will hold the joint together. So, the tapered mortise and tenon joint for chairs achieves multiple goals. One is that you're able to have a much bigger supporting end and not as big. This is going to be, imagine this is a seat and this is a leg. It's drilled at an angle. The support is bigger than the part that comes through the seat that will be possibly visible through the seat itself, maybe even through the paint. In the process of making this tapered joint, I'm able to get the angle exactly right, because I'll show in a second how I'm doing this. It's a slow process that allows me to make this compound. If you think about it, this is a compound angle. It leans back to front and side to side as well. And when I'm assembling this, it doesn't become tight until very last moment, so I don't need to size the joint with hide glue, because not much of it is actually going to get sheared off. In addition, to make it even stronger, I'm going to wedge this joint from the outside and really lock it in. So the tools to make this tapered joint are a reamer and a tenon cutter. They're pretty easy to make. The reamer is just a piece of steel, or you can use a saw blade. Cut to, this one is a 6-degree angle. And then you sharpen the ends at either 45 or 70 degree. Those are 70 degree. So it works just like a scraper. And then a housing body that holds it in place. The way to use it is you apply most of the pressure down to make sure that you're going along the way, but I'm able to adjust the direction of this joint by applying some pressure as I twist it in the direction I need to adjust. So I will drill this mortise to be close to the angle I need to hit, and then I will double check it in both dimensions, and just by providing a little bit of pressure sideways, I'm able to ream it to make exactly the right joint. And because it's a scraper, the surface is very, very nice and clean. The tenon cutter is actually made with the reamer. Once you have the reamer, you just make this mortise to match with the reamer, and then cut it and add a plain blade, so it works just like a pencil sharpener. So this is how this tenon is cut. Okay? Once I've assembled the joint, I'm going to mark the direction, make sure again that my growth rings go perpendicular to the long wood fibers in the seat. I will mark the depth, how deep it goes into the seat. And so now I already marked here where I'm going to cut the slot for the wedge, and then I'm going to saw the slot for the wedge going about 1/4 inch above the depth mark. So that's coming next. it's useful to introduce a little V-cut with a file just to help the wedge go in. So to assemble this joint, again, I'm going to align the leg and a seat. Make sure my growth rings go perpendicular to the long wood fibers. Also notice that the direction of the wedge is very important. You don't want to split the seat with the wedge, same as you wouldn't want to split the wall that you're putting your wedged mortise and tenon joint in. So make sure that the wedge is going to open along the longitudinal wood fibers. And one additional piece of information about making this joint last longer is that we're going to introduce a little bit. So normally I would add glue to it when I'm assembling a joint, but if you think about wood movement and the stresses that will be applied to this joint in the chair, there's going to be some movement. And when we glue in the joint, we're going to introduce a little bit of weakness into it by applying glue just to one side of the wedge. So this is known as an expansion joint. What it allows is that if there's going to be a crack opening up in this joint, it's going to be between side of the wedge and side of the leg, where it's very inconsequential, instead of the glue surface pulling the leg away from the seat. So again, this small trick of just applying the glue to one side of the joint is very useful. When the wedge is fully seated, you can tell the change in the sound. It goes from high tone to kind of hollow. That's it. We're there. It's fully seated, not coming out.